Hello everyone. In this video, you will learn how to make sense of the definition of a derivative. As you can see here in the very top, you probably have seen it before from your textbook, from your teacher in the classroom, that we have seen this, but a lot of people, they don't really understand what this equation is all about. They just memorize it, and I really don't want my students to memorize this equation, because this equation is very, I would say, very elegant. It's a genius equation. So in order to understand this equation, we need to make sure we understand a very crucial diagram and some fundamental knowledge that we have learned in Algebra 1 or even earlier. Now, let me remind you one thing, which is what is the what is the equation of a slope? Now, many of you should be able to say it, that m, which stands for slope, m is equal to y squared, no, I'm sorry, y2 minus y1 over x2 minus x1, y2 minus y1 over x2 minus x1. Some people would also say m is equal to change of y over change of x. Okay, either way works. And now let's go ahead and draw a diagram to illustrate this. Now the key transition between calculus and any courses before calculus is that before calculus we will say, hey, let's go ahead and find a slope. All right, give me 2 points. So we have two sets of coordinates. We have x1, y1, and then we have x2, y2, and then we can go ahead and use this equation and find out the slope. Okay, so let's go ahead and draw a picture to illustrate this kind of concept. Okay, now we have a graph right here. Let's say we have 2 points. Okay, we have a point right here and we have a point right there. Okay, and I'm going to use dashed line to connect these 2 points. I hope that I can draw this dashed line perfectly. Yes, pretty good. Okay, and we can go ahead and find the slope between these 2 points as long as we have the coordinates, right? Now, let's do a little bit more challenging right here. Okay, let's say this graph is going further directions. Now, we'll go ahead and label this diagram. Let's say this graph, it's a representation of function x. And then let's say this x here, it's this point right here, we call it x. Now, what would we call at this point? In Algebra 1, before we learned anything like functions, we would just say y. Now we learn about functions, so we will say this is called f of x. Okay, I think it's very easy to understand this is f of x, and we will come up with a coordinate pair. So this will be x comma f of x. Okay, all right, moving on. Now let's label this point, this x value. Now, how should we label this x value? Should we label this as x2? Well, we could do that, but let's do it in a way to help us understand what's going on with this equation. So let's say we have this distance right here, and we call this distance h for no particular reason, but I would like to call it h. And so what will this point be? Okay, what would this point be? This point, it's going to be, let's think about this. Now, some of you may be confused at this point with this h right here. Let me give you a simple example with numbers. Let's say we have this x as 2 and this distance as 3. What would this point be? Then you would say, oh, it's 5. It's very simple, 2 plus 3, right? So if you understand this concept in numbers, then you should be able to understand this concept with these letters. So we can call this x plus h, okay? And if this is x plus h, what would be the y value be, or the function value be for this point? Okay. Now, if you understand this is f of x, simply put the x into the function. We have f of x. Now we have a different x value. It's called x plus h. We put this x plus h value into the function. We called it f of x plus h. Okay. And the coordinate pair for this point, it's going to be x plus h, comma, f of x plus h. Now, this is not something that you have seen before, and I totally understand that, but if you understand where we have x plus h and how we have x right here, and that's f of x, you should have no problem understanding this is f of x plus h, and we just put the x and y values together. As simple as that. Nothing really complicated. Now at this point, if I say, hey, can you go ahead and give me a slope equation between these 2 points? And I would say, sure, no problem. No problem at all. We would say, all right, y2, let's say this is my second point. My y2 will be this, f of x plus h, and minus y1, which is this guy right here, f of x, okay, divided by x2, which would be my x plus h right here, put a parentheses around them, minus x1, simply x. So simplify this a little bit. So my slope, it's going to be f of x plus h minus f of x over, now you can see the x got canceled out, so you can see the h right here. And at this moment, you'd be like, wait a second, I see something very special, because I can see this right here, which looks just like this over here, except that we have a limit over here. So what's this limit all about? Now, let's think about this. In Algebra 1, in Algebra 2, when you are asked to calculate slope, you'd be like, okay, yeah, give me 2 points and I can calculate that. And if I ask an Algebra 1 student or Algebra 2 student that, hey, can you find me the slope of a point? Then they would probably answer you, well, we need 2 points to calculate slope. We cannot calculate the slope of a point. So it's not going to work. Now, how can we make use of the slope idea, okay, which is the slope between 2 points, to find out the slope of a point? Okay, now that's the genius part. Now, let's think about this. We have these 2 points right here, okay, and we only have paper. I don't have cool, fancy computer technology, so I cannot really show you some kind of animation, so I will rely on your imagination. I would like to ask you to imagine that this point is going to move, okay? It's going to move along the curve, okay, on this line. And as it moves, this secant line would also change. So imagine that this point is going to move to here, and the secant line would connect from this point to this point, okay? So I need you to imagine and think about this diagram somewhat dynamically. So we will move this point closer to where? To this point, okay? So it's going to move, and it's going to move, it's going to move all the way very close. Now, the key fact right here is that these 2 points will never ever overlap with each other, but the second point is going to move closer and closer and closer to the first point. Now, how close should we move it to the first point? It will be so close that you will have to use a super powerful microscope to see where these 2 points are, and they are separated by a very, very small distance, okay? And then you think about this. All right, so if something that has to be seen under a microscope, what about without a microscope? What if we just look at a diagram with naked eyes? It's kind of hard to observe the difference, but I'm going to tell you this. I'm going to convince you that these 2 points, as the second point moves toward the first point, they are going to be very, very, very close, but they are not going to overlap with each other. Okay, so keep this in mind for the moment. Now let me address another key feature here. As the second point moves toward the first point, what is changing? Okay, we can see the point is changing, the secant line is changing, but there's another great thing that's changing. The h. The distance between these two x values, it is diminishing. It is getting these 2 points are getting closer and closer. The distance between these two x values are getting closer and closer and smaller, and h is getting smaller as well. Well, where is h getting to? Well, h is heading toward 0, but h is never going to equal to 0. Now, this is very important because this concept is exactly what the limit is, when we say limit of h approaching to 0, we're just saying that this distance is going to get smaller and smaller, getting smaller closer to 0, but it's never going to be 0. Now, how does this play out? Okay, so let's go ahead and magnify this, okay, a little bit. So let's say I'm going to draw a diagram right here. Okay, so underneath the microscope, okay, this is the field of view underneath the microscope, and this is the part of the curve right here. So you're going to see this is point 1, this is point 2, and they are separated by a very, very tiny distance. But with naked eyes, you are not going to see it. And this is how we define the slope of a point, by using the slope of 2 points and saying that the distance between these 2 points are getting closer and closer to 0. And that is exactly how we have this equation to define the slope of a point, or the slope of a function, or the slope of a particular point on a function, by using the limit of a slope equation. Okay, now, how is that important? That is very important because let's say we have a problem. Okay, the problem is going to be like this. Okay, so I would like you to find out the derivative, okay, of limit as h approaches to 0, okay, of 6x plus h squared minus 5x squared over h. Okay, so let me draw a line right here to separate everything else. Okay, all right, now, so for most of you, be like, okay, let me go ahead and calculate. Now, I'm sorry, there's a type, I wrote something wrong right here. It should be 6x. Okay, now, for some of you, you may think about expanding this, doing the FOIL, but if you really understand this concept and you understand power rule, okay, which you will learn, either you have learned it already or you're about to learn, we can analyze this expression very quickly, which is, well, this is the derivative definition. What is the function that we're talking here? Okay, and if you can compare this expression with this expression side by side, well, this looks like the f of x. So this is f of x, 6x squared. And if you know how to use power rule, then you'd be like, hey, I know what the derivative is without even expanding this x plus h squared, because with power rule, I know that it's going to be 12x. And this is how understanding the origin of this expression will help you do this kind of problem to analyze much better.